This is Jeff Scott of Black Hawk Technical Colleges. I won't be here on Wednesday, April 1st, no April Fools. I'm taping the lecture for the 152-142 Intro to .NET Programming C# class on Saturday. And I'm hoping to spend about an hour or so going over the material in Chapter 7. I've got the book up, and I've even got someplace over here. I've also got the PowerPoints up. So if I need to reference those, I can. If I have to, I will also bring up the program that we worked on as a class, although, in fact, I'll bring that up right now. Hopefully by the time you watch this, it'll be around Wednesday, and we'll have gone over the material for Chapter 7 in class, or gone over the programming example, I should say. All right, so let's just start at the beginning. I think we're making very good progress in the class. Again, this is me speaking, but we're up to page 397, and remember, this is the last chapter for which you'll have homework. All right, Chapter 7. And that'll be to do this array fun program, as I called it, that we're doing as a class, and then this population program that's at the end of the chapter. So you can see here we've got 9 different topics that we're going to cover, and some of them are review. Value types and reference types we've talked a little bit about before, but we'll hit on it some more. Array basics. Now, most of you in this class, and granted, not all of you, but really the prereq for this class is supposed to be the 152-119 JavaScript class. And the reason I say that is if you've already had the JavaScript class, you've been introduced to arrays already. And there's a good chance if you haven't had the class, you have not been introduced to arrays, which we're going to get into in this chapter. The good news is if you're in both this class and the Java class, Chapter 7 in Java, as I just tried to show you just a second ago, is called Arrays in the Array List. Well, this chapter is called Arrays and Lists. So basically, it's the same type of material that's presented, but for each language. All right, we'll learn how to work with files and arrays, how to pass arrays as arguments, some of the different array algorithms, and again, we'll go over those, plus I will show you those in relation to the program that I'm doing with you. Advanced algorithms for sorting and searching. Two-dimensional arrays, also called multidimensional arrays. I'm always amazed at the number of people who tell me that I really don't get arrays, and especially two-dimensional arrays, I don't get them. But then I will talk to those same people, and as an example, and I just want to show you this. So you'll come in here and you work on Excel. And what's Excel? It's a two-dimensional array. This is cell A1, right? Column A, row 1. Column B, row 1. Column A, row 9, etc. Well, the only difference is if you're talking about a multidimensional array, these are numbered from 0 and up, and these are numbered from 0 and up. So instead of A1, this would be cell location 0, 0. This would be 1, 0. This would be 0, 1, 1, 1, etc. All right. We'll also talk about jagged arrays, which are a fairly recent development. What they say is when you've got a multi-dimension array, and let's suppose, for example, you've got an array that's supposed to look like this. All right. In other words, there's 1, 2, 3, 4, 5, 6 columns, and 1, 2, 3, 4, 5, 6, 7, 8 rows. All right. So it's an 8 by 6 array. And maybe I want numbers. Okay? And I'm just going to take and copy these numbers down. You'll see why in just a second. All right, so this is all filled the same. But with a jagged edge array, what I might say is, for example, now you'll notice if you take a look in here that not every one of the rows has got the same number of columns in it. That's a jagged edge array right there. All right, and we'll look at that in just a little bit. Finally, we'll talk about the list collection. Now, I want to mention something, and this may or may not make a lot of sense to you when we first start, but I want to mention it now anyway. When they talk about the list collection, what you're able to do in both C# and Java is rather than create an array, you can create an array list. Well, what's the difference? If I create an array, and let's just make it a simple one-dimension array, all right? So it's an array with just basically, let's make it 10 columns. Oops. All right, and we're actually going to just start that. So the first one will be column 0. All right, because that's how we, being computer people, that's how we start. Let's, all right. In fact, we'll get rid of these two. We'll just move it all the way up to the top. So if this array right here that I'm creating right here, all right, let's just suppose it's called numbers. All right, and that has no significance to the name other than the fact that the array is going to hold numbers. Okay? So if I said something like, let's just start over again. Int bracket bracket numbers equals, and then I put in curly braces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you might think, well, we just did, so what? Big deal, who cares? It is kind of a big deal. All right, I just want you to know with what we just did there, it's kind of a big deal. And it may not make a whole lot of sense right now, but I really and truly believe that it will when we move on a little bit. Now this line right here results in memory looking like this. Now you know that as well as I do that in memory, all those things that are in there are not really numbers 0, 1, 2, etc. They're binary equivalents. And that's not really important. It really and truly is not. But what I want to show you, and again, this may or may not make a lot of sense right now, this line right here is the same thing as saying numbers 0 equals 0. All right, and then just I think it's important enough to take a minute to go through this. Whether it makes a lot of sense to you or not right now isn't all that important, because if it doesn't, then I'd say, first of all, in all seriousness, as I've said to you many times before, read the chapter. As he usually does, Gaddis does a pretty good job in here of going through the material, in my opinion. So you can see what I'm showing you right now, and yeah, I'm taking a little bit of time to do it. Maybe you think you're wasting a little time doing it, which is okay. But if you look at it, this is a lot more work. And I'm going to show you a little later another way we can do this same thing, which is going to save a lot of time if we want to do it programmatically. So we'll look at that in just a little bit. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now this sometimes either bothers people, confuses people, or upsets people in that the first array location is location 0. So again, this line right here, or these 10 lines right here, results someplace in memory. Is now we've got an array, and that array is referred to as numbers. And the 0th location for numbers is going to hold 0. The 1 location for numbers is going to hold 1, etc. But you've got to look at it this way. There's the 0th location, and notice what it's holding. All right? You might say, well, you really should have put a 1 here and a 2 here, etc. We could have done that too. There's nothing that stops us from doing that. All right? But I'm going to grab what we just did here. I'm going to grab all of it, copy it to the clipboard. I'm going to create a new sheet, and I'm going to paste it in. And you might say, well, that's fine. Why did you do that? Well, I'm going to change all these. So now what we have is we've got a string array. And now month 0, for example, is going to be equal to Jan, which sometimes bugs people just because of the fact, well, it's not month 0 isn't Jan, month 1 is Jan. So if that's the case and you're like, well, that bugs me, I don't want that, then start it at 0. Alright, so start it at 0. And this will not be an int, it'll be a string, months, bracket, bracket, equal, and then what we're going to put in here is nothing for the 0th element, Jan, Feb, Mar, APR, May, June, July, you know the drill, August, September, October, November, and finally December. Now I'm hoping I'm showing you the right syntax. If I'm not, we'll fix it up a little bit later. Alright, that would need a semicolon at the end. So again, 0 now would have nothing in it but the empty string. And as we move our way down, that would have January in it, February in it. Hopefully I don't have to keep going, you just, whoops. So the first one would have Jan in it. Fine, keep going. Trying not to waste too much time here, and if you think I am, sorry about that. Now you're not going to be able to see all this on the screen just because we're out of room. And the reason that I'm doing this, and the reason that this becomes important also, just so you're aware of this, is sometimes, now with everything we've done so far, we know we're initializing our array. So we know everything that's going to get in it. But sometimes, fortunately or unfortunately, you don't know ahead of time what's going to be in there. So again, this right here that you see in gray is the same thing as this right here, and that results in memory someplace in this. Again, with the 0s and 1s, the binary equivalent of May, June, etc. Alright, in much the same way of what we just showed right here. Alright, let's jump into the chapter because I'm already falling behind. Alright, the data types in C# and the .NET framework fall into two categories, value types and reference types. Virtually everything that we've done thus far has been a value type. So in other words, when we do this, so when I come in here and I type in int age, you've seen this countless times, or if I type in string name, alright, or if I have Boolean, alright, those are all simple types of variables. They're also known as primitive types of variables. All right. So if we say something like, I can make it a double or a decimal. Let's say $40,000. $45,000.37 as an example. Let me line these up a little bit, pretty it up so it makes it easier hopefully for you to see. So these are examples of primitive types of variables. They're also known as atomic variables. They can only hold one value at a time. So if later on in my program I say age equal 58, now that value, that 21, has been replaced with this value. So age can only hold one value at a time. Same with decimal, same with same with salary, same with name, same with married. All right? These are all simple variables. So when you talk about simple variables, you've got numeric, which are basically your int, and you've got several types, like a long, a short int, etc. All right? But they're whole numbers. You already know all this stuff. All right? Then we've got float, double, decimal, and they've got different variations. There's long floats, there's, long doubles, etc. All right? Then we've got strings, and actually strings are kind of a different one. So we'll hold off on that one for a while. But then we've got booleans. All right? The same things in Java, so this is in C#. But just as a little prelude, so to speak, for you, when I give the Java lecture in a little bit, in Java, those primitive variables, whoops, are byte, short, int, long. Those are all the regular numerics that can only hold a single value. Float, double. Those are ones that can't hold a decimal place. Char, and boolean. There's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. There's a char in here too. And I think I'm saying this right. M init, so that's my middle initial, equals, I think this is how you do it in this language. We're going to probably see it later on in the chapter. So I've shown you. And again, all byte, short, int, and long they're different variations of int. And all float and double are their different variations of decimal. There is no decimal type in Java. Char I just showed you, and boolean I just showed you. Let's map them up here. All right. Those simple data types that I just showed you, if you pass any one of those simple data types in the regular way into a function, they're passed by value. So a copy of the value is passed, not the value itself, if you remember this from an earlier chapter. But what we get to when you start talking about reference types is with a reference type, you don't pass in a value. You pass in the address of the memory location where the value exists. So with a reference type, which we're going to get into because an array is an example of a reference type, any change you make is a permanent change. So when you think copy by value, think you're working with a copy, so you're changing a copy if you change it. If you think pass by value, all right, you're changing the real thing, and it's a permanent change. So it says when you work with a reference type, you're using two things. An object created in memory and a variable that references that object. Now they're being very literal, or Gaddis is here, where I'm not being as literal. I'm just trying to show you literally what's happening with the system. And he gives an example here, and he says, look what happens when you do this. When you say random rand equals new random, the first part of the statement, that which appears on the left-hand side of the equal sign, the random rand, all right, it says it reads random rand, so it declares a variable named rand that's of type random. All right, that's what this does. The second part, the new random, it creates a new object in memory and returns a reference to that object. So again, since it's a reference, Any change that we're going to make is going to be a permanent change. And that's what they talk about here. All right, let's jump into array basics then on page 392. As it says, an array allows you to store a group of items of the same data type together in memory. Processing a large number of data types in an array is usually easier than processing a large number of items and stored in separate arrays, which is true. So imagine, and I'm going to shrink this down a bit. First of all, let me give you my definition of an array. It's similar to Gaddis's, but it's not identical. All right? An array is let's put it this way, a C# array and a Java array. With both of them, they're a set of contiguous memory locations, each of which holds the same type of value. Now this is different than what we looked at, just so you know, this is different than what we looked at in the JavaScript class. In JavaScript, you can have arrays that have different data types in them. You can't do that here. This is the key thing. Same type. Arrays in Java and arrays in C#, these arrays are what are referred to as early binded. In other words, they are set at compile time. When I say they are set, I should say, how about this? The size is set at compile time and cannot change. All right? But, for example, a JavaScript or PHP array, those kinds of arrays, let's just say JavaScript or PHP arrays, are what are called late binded. In other words, the size is set at runtime and can change. So you can make them bigger or smaller as the program goes along. You cannot do that in a C# array or in a Java array. C# supports lists, which we'll talk about at the end of the chapter, where you can do that, and Java supports array lists where you can do that. But a straight array, you can't change the size once it's been set in either C# or in Java. All right. Now, he goes through an example here, and there's absolutely nothing wrong with his example. All right. But I'm going to go through a similar one. Okay, because I think that mine is going to work out a little better. Again, not to say I'm better than him, nothing like that at all. All right? But I showed you this stuff before. Okay, and I'm going to change this around. I'm going to do this. I'm going to say that I have 10 people in a class, and I'm going to say all 10 of them took a test. So the grade of the first student is a 73. And you can hopefully guess what I'm going to do here. So, all right, the grade of the second student, the third student, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. 73, the next one, let's say they got a 55, the next one got an 89, a 100, the next person didn't take the test, okay, so I have 10 people who took the test, and these are their grades. That's fine. The point is I'm making 10 different variables in order to do that. With an array, I make one variable, right? With an array, I make one variable, and that one variable is going to hold all of these values. You saw something like this before. And if I want to refer to any of these grades, so now if student 5, all right, if student 5 took the test, and let's say he got 80 on it. All right, remember that's in here, that's grade 0, grades 1, grades 2, grades 3, and grades 4. So I'd have to come down here after the student took the test and say grades of student 4 equals 80. So that's going to change that value or that value from a 0 to an 80. All right. Now, sometimes when you create an array, you don't know how big it is. So in other words, if it's the beginning of the semester and I don't know how many students I'm even going to have in the class, I might make an array that says int bracket bracket students equals new, trying to make sure I'm giving you the right syntax here, because it's a little different between the two languages, int, and let's say all that I know is I've got 25 students in the class. All right. Well, most of the time, C# tries to help you, and it tries to take that and put zeros in each one of those values. But what if I want to make sure with these new students, let's say it's a string. String students blank equals new string. Okay? And I want to make sure that I've got something like this, but I've got all 25 students, and I want all of them to be equal to the empty string. Well, then I can just come in here and say for int I equals 0, I less than 25, because again, we're going to count from 0 to 24 here, I plus plus students sub I equals the empty string. Now what I've just done is the equivalent of this, but with string here and students here and the empty string 25 times. Arrays and loops are meant to work together, and I'll come back to this example later because there's another way that we can write this using an enhanced for loop. So we'll get to that in a little bit. All right. So they show some examples that are very similar to ones that I've given you. Again, you may like mine better, you may like the ones in the book better. It really and truly doesn't matter. I've shown you the array initialization that they mentioned here on page 397. All right. Using a loop to step through an array, I've even kind of shown you that already. All right, now imagine with these grades right here, so let's look at this example that we just did. All right. So I wonder, let's pretend for a second that we've got these right here. And now it's the next test. All right. So I'm going to call this in bracket grades. That's fine. Let's just say I'm going to make another one here. I'm going to say int bracket test2 equals new int 10, like we had before. But with this for loop like I've got here, I can write a loop, and inside of here, I can say get student I, really it's I plus 1, grade, or test grade. So the first time I run through it, I'll get student 1, then student 2, then student 3. Student 1 is actually a 0 in here, etc. So that is going to end up being a 10. As always, please read the chapter. All right? Invalid subscript. There's an error in this code right here. It says size is 3. That's our constant. Okay? So we're making an array of size 3, which means it'll hold elements 0, 1, and 2. So this says, while it's less than or equal to size, so that's going to attempt to put something in 0, 1, 2, and 3. So it's going to attempt to stuff 4 pounds worth into a 3-pound bag. And we're going to get, basically, you're going to get an error and the program's going to break. If you don't understand that, take a look at it. Write the code. All right, the length property. Show you this like this. Instead of saying 25 right here, we could have said students.length. Let the system figure out for us how many elements are in the array. Like that. Okay. Remember that an array's length property can only appear on the right-hand side of an equal sign, not the left-hand side. You can't manually set the size of an array because, again, it's set at compile time. Using a loop to step through an array, I've already shown you, again, invalid subscripts, the length property. There's a kind of a neat little program here with random lottery numbers. So they're going to fill these 5 things up with different numbers. And I believe at least he keeps it really, really, really simple. The way that his is set up, it would be possible when you run this to have the same number appear more than once. All right, so you can take a look at that if you want. The off by 1 error I just showed you. All right, here's the enhanced for loop that I mentioned to you earlier. Okay, it's also called a for each loop. All right, with a for each loop, all it gives you, or what it gives you, is a little easier syntax to work with. So let's go back and look at our example before. All right, and it doesn't matter which of these we choose, but let's do both of them. So I could rewrite this as a for each loop. The for loop that you see here can be written as a for each loop by saying for each int in fact, that's going to be, we'll say string name in students name equals, and I believe I'm giving you the right syntax there. I'd have to write a little program to show you, but I believe that that's correct. In fact, let's see. That was grades, so that was grades. And I did a string one there. These were tests, so let's copy this one down. I'll save this file when I get done. But you see with a for each, you write a little bit less here. Oops. So that would be int tests in test 2, something like that. Okay? All right. Reassigning a value, I already showed you that. That's on the bottom of page 402. Working with files and arrays, I'm jumping back into the book and I'm up to page 404. Now you have to read this section well. It's not long. 404, 405, 406. 3 pages. The program that you are going to do for this chapter, all right, the program you're going to do for this chapter, I've got it in here you're going to use that file, which has got a list of populations for a bunch of years. All right, and based on that file, so based on this file that's got all these different values, so it's got what? 40 years or 41 years of values. Okay? And based on that, you're going to run the program, and it's going to do this. Simple list box with 3 buttons, a clear button, an exit button, those are nothing, and a show data button. And you're going to basically reproduce all that data that you saw in there. So again, notice 151,868. That's for the year 1950. 153,982, etc. And then what you're going to do is you're going to say, okay, I want my population from 1950 to 1951 went from 151,868 to 153,982, which was an increase of 1.39%. Your program's going to have to figure that change out. Then it's going to have to go through that list and say in that list, the biggest change that we had was in the year 1984 that you can't see on here, but the value was, or the smallest was 1984, was 0.87. The biggest was 1955, which was that number right there, 1.97. All right, so that's what you're going to have to do for your last assigned program example. So you're going to be working with a file that holds numbers. And rather than writing the array contents to a file, you're going to be reading the values from a file and manipulating them. So you're going to do something like this. So please read all of pages 405, 406, or 404, 405, and 406, and in particular the bottom of 405 and all of page 406. Okay? All right. You can pass an entire array to a function if you want to do that. Notice that when you pass an array, inside of here you've got to say the type of the array, bracket, bracket, and the name that you're going to use. Arrays are always, when you pass an entire array, it's always passed by reference. If you pass just an element of an array, it's passed by value. So if you want to make permanent changes, you pass the entire array in. And that's what they're showing here on pages 407, 408, and 409. All right? Jumping up then to 410, and I'm not trying to go through this too quickly. I'm trying to show you simplistic general examples that I'm hoping are going to help you understand this stuff. So the idea, again, as always, is you do this, you go through this particular example or this particular lecture along with the one that we do in class, and hopefully it gives you enough information that arrays are a little bit more understandable for you. It says when you saw in the previous examples, arrays are always passed by reference. When you pass an array as an argument, the method has direct access to the array. However, the method cannot access the original array variable that was used to pass in the array. So it says here, for example, the following code shows the event handler, so let's see. He runs through all of this stuff, and what he gets to in here is he says, okay, you've got this original array. All right, and if you call change array, okay, it says make the array reference a different array. What they're doing right there is what they're saying is you can't sit there and directly say, okay, this array called numbers had 3 in it and now has 5. You can't do that directly. Read through that. All right, it's a little bit confusing for lack of better words. So I'm not going to run through that any more than that for right now at least. All right, some useful array algorithms. Starting on page 414. And the first thing that's in there on 414, 415, and the first half of 416 is a sequential search. All right, imagine for a second with these examples that we've been going through. All right, so imagine I'm gonna go down, give myself some room here. Imagine I had a list of 10 numbers, and these numbers mean nothing. I'm just making them up. Let's say that they are test grades. Okay, and they didn't do very well looking at this. 6, 7, 8, 9, and 10. All right. So let's say I'm going through this, and I want to know, so here's my question. Did anyone in the class, let's say that we add all these up. Okay? In fact, let's do that, just so you can see. This should actually work for what I want to show you. So, 77 plus 33 plus 56 plus 77 plus 8 plus 99 plus 0, which we didn't really have to do, plus 12 plus 56 plus 100. So the whole class collectively, if I added that right, got 518 points. All right? So if I divided that by 10, I'm going to get 51.8. So I'm going to round that up to 52. So did anyone in the class get a grade that was the class average? In other words, a 52. Well, how would you do this? You can whip through this yourselves. No, 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 etc. So the answer is no. The computer's not as smart as you. All right. So if you want to write this for a computer, you'd have to do something like this. All right. So let's assume there that we've already got the array made. So again, 77, 33, 56, 77, 8, 99, 0, 12, 56, and 100. I don't really need those numbers anymore because they're here. All right? So I'm going to come in here and write myself. So I'm going to say Boolean. I'm going to make a variable called found. And I'm going to set that equal to false. Okay? And then I'm going to do this. I'm going to say, okay, for. I'm just used to using a regular int. Int I, or a regular for loop rather, equals 0. I less than, in fact, I'm going to make one more constant in here. So I'll say const avg grade equals 52, because that's our average. We already said that. All right, so I'm going to go from 0, and while it's less than grades dot length, I want to keep going. All right, so I++, all right, so this is going to be a function, so call, let's see, Boolean found equal false. So I'm going to say found equals, did anyone get the average grade? Kind of silly to do it like this, but it'll work fine. All right. So, and I'll pass grades in to that program. All right. So there'll be some more code in here. Okay. So I'm going to say private void, not even void, private Boolean, and this is my name. Okay. So I'm going to go through my for loop, and I'm going to say if grades sub I, so if the current grade is equal, if it's equal to the average grade, So if it's equal to that, return true. And if I get all the way through it, and if I haven't found one, I'll return false. So play computer for a minute. Don't worry about this stuff. Let's say that's done at the top of the program, and I've got a main, and let's say all that stuff is in main. All right, so here, I'll say here, declared at top of program. Okay. And this will be declared in our main routine. And where I've got the dot, 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 there's just some code here. All right. So what we've done is we've got that right there. And we've already figured out that that's our average. And we want to know, did anybody get the average age? So we're telling it here to cycle through those 10 grades. If the current grade that we're looking at, which would be grade sub I, so that'll be grade sub 0, grade sub 1, grade sub 2, grade sub 3, all the way up through grade sub 9. If it's equal to the class average, which is a 52, return true. If I get all the way through and I haven't found it, return false. If you can understand that, you understand exactly how a sequential search works. Think about it this way. Let's suppose that I want to find out if there's a person with my name, in Janesville, and I'm given a copy of the phone book. Well, you say that, well, that wouldn't be very hard. You know, if they, you know, you'd go to the S's and you look under Scott, you look and see if there was a Jeffrey. Right? No, this is a different kind of phone book. The names aren't in any kind of order. They're more or less like this. They're in no order. So I'd have to look through the entire phone book. In the best case, it would be the first name in there. In the worst case, I'd look through the whole phone book and it wouldn't be in there. Maybe the number's unlisted. All right? So the bad thing about using a sequential search like this is that typically it's very slow, because you typically, on average, have to look through half the array to find what you're looking for. And in the worst case, you got to look through the entire array, and it's not there. That's what they show in here. So the example that he gives, which of these was one of the original 13 colonies? And you go through there, and quite often what you do is, if you don't find in there what you're looking for, rather than returning false, as I showed you, you return -1, which just means not there. Now this is a fairly simple program, and he does an excellent job on the bottom of 415 and the top of 416 of going through it line by line. So I'll let you look at that on your own. Copying an array. Notice this. I'm going to grab all of their code right there. Copy. I'll come back. I'll use this one. That one's just got some text in it, so I'll come back to the other one. All right. So again, let's see. So we did some stuff here. We did some more stuff. I'm just going to put some delimiters in here so you know kind of where I started and where I ended, etc. All right. Oop, I wanted to copy that, and of course I just undid it. Copy. If I've set up an array like this that has 2, 4, 6, 8, and 10, so the even numbers between 1 and 10, and then I do this, that does not copy everything that's in here into here. Instead, it makes an alias. Now both array 1 and array 2 now both point to the same variable. If you don't get that, that's exactly what the author is showing in the picture right here on page 416. All right. If I want to compare array values, so if I want to find out if it's the same array, then I have to compare them an element at a time. All right. totaling the values that are in an array. So again, going back to the example that we looked at before, where I showed you these. If I wanted to figure out that average, I just added them and divided by 10. But I could have also went in here and done this. For, in fact, we'll come in here, we'll say int total equals 0. For int I equals 0, I less than, what do we call that, tests, test.length, I plus plus. Total plus equals tests sub I. So what that's doing right there is this loop that you see that's in here, that loop is going to be, say, 7 plus 33 plus 56 plus 77 plus 8 plus 9 plus 0 plus 12 plus 56 plus 100. So when I get done, total will now be equal to 518. And that's exactly what the author is showing you in the book here on page 418. What if I want to average those values? Well, guess what? I'm almost done it already anyway. So if I come up with one more variable in here, which I should have given myself room for, but I'll just put it here, that's fine. We'll say double AVG, and we'll set that equal to 0.0, that's fine. So now I can come in here and I can say AVG equals, now if I do this, if I say if it equals total divided by tests.length, remember it's going to divide 518 by 10, but since it's an int divided by an int, it's, instead of saying 51.8 and rounding to 52, it's going to say 51.8 and drop that. So I'd have to cast either this one, or as I'm showing you right now, both. Now average is going to be equal to 52.0. And that's the program that they show on the bottom of page 418 and the top of 419. All right. Finding the highest and lowest values in the array, which is on 419, 420, and 421. See if we can keep throwing that in here like I've been doing. All right. So let's say that I come through here. I'm going to create two more variables. Int lowest, and I'm going to assume that the lowest is the first array element. So it's going to be tests sub 0. And just to make it simpler on myself, I'm going to have another one that's called highest, and I'm going to assume that that one is also the first array value. So now I've shown you in here how we can get the total. I've shown you how we can get the average. So let's show you quick how you can get the highest and the lowest values that are in there. All right. So while I'm doing this for loop, this is going to look a little ugly for a second because these numbers are going to shift down, but that's okay. So I can also come in here and say if the current test, which is tests sub I, if that value is less than lowest, it's now our new lowest. So lowest equal tests sub I. All right. And the good news is it's the same exact code for highest, except I want to change every instance of lowest to highest, and I want to change the less than sign to a greater than sign. See if I can grab these values and put them back in here. So now all of this stuff that I just showed you is in the chapter. It's also in the array program we did. But what I've just shown you is how to figure out the total of all the array elements, how to figure out the smallest array element, how to figure out the largest array element, and how to figure out the average size array element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't need that anymore. And you can see how compact it is to do that. All right? So, jumping back into the book up to page 422. This is a partially filled array. So sometimes when you're filling up an array, you don't know. So maybe I've had 7 or 8 students take the test out of 25 and the rest missed for whatever reason. So I can partially fill up an array. And they show you that on 422, 423. And I'll let you read that on your own. All right. Advanced searching on page 429. First they talk about a selection sort. And basically with a selection sort, as it says, you want to rearrange the data in some specific order. All right? So typically you want to take something like this and you want to put it in ascending or descending order. So what you want to do is you want to basically find, okay, you look through the whole array and you find the smallest one, 1. So you flip that with whatever was in that value before. So now you've got 1, 7, 2, 8, 9, 5. You do it again, and now you don't have to check the first one, so you only check here. So the 7 and 2, you flip them. So you now have 1, 2, 7, 8, 9, 5. Then you come through here again, and now the 5 that's here is the next smallest, so you now have 1, 2, 5, 8, 9, and then these don't have to be flipped. So when you get done, you'll have 1, 2, 5, 7, 8, 9. All right? And they show you that one at a time in here, much better than I just did. I'm trying to keep this as close to about an hour or so as I can. I'm coming up on an hour right now. And they go through the whole swapping mechanism that takes place in here to do this. It's a good program he gives in here. All right. Next he jumps on page 434 into a binary search. And let's again look at this and try to keep this simple. Here were our numbers. All right. I'm going to grab these numbers again. And then I want to grab that code that we put in there and remove this code. So. Oops. That was 133. All right. A binary search algorithm that they start talking about next on page 434 is also called a halving algorithm. H-A-L-V-I-N-G. So imagine I took this array that you see right here and I put it into sorted order. So now it's 0 followed by what? 7 followed by 8 followed by 12. Hopefully I'm not screwing this up. Followed by 33, followed by 56, followed by 77, followed by 77, because that's in there. I thought that was in there twice. Isn't that a 77 the first time? Nope, it's 7. So we've got 99, and we have, and I'm missing a number, 100. So what am I missing? 33, 56, 77, 8, 99, 0, 12, 33, 56, 77, 8, 99, 0, 12, 56, and 100. What number here is repeated? 56. So that's 100. That's 99. That's 77. And that's 56 again. All right. So now the array is in sorted order. So now if somebody comes in and says, did anybody get the average of 52? What you do is you go and you look at the values halfway through. 1, 2, 3, 4, 5. So we'll look here. and we go, okay, is that the number? In the best case it is, and I know that it's there. Well, it's not. Okay, well, is the number I'm looking for greater than or less than that number? Well, it's less than. So now I know that it can't be this number, it can't be this number, it can't be this number, this one, or this one. So in one guess, I've eliminated 50% of my possibilities. So I cut it in half again. I go, okay, is it this number? No. So now it has to be either this number, or it's not there. So I keep cutting my list in half all the time, and that's why I said, and this is shown on 434, 435, and 436 in the book, it is a halving, H-A-L-V-I-N-G type of sort. All right? All right, jumping up to 436. The author starts talking about two-dimensional arrays. And again, very similar to the spreadsheet idea that I showed you before. That's 0, 0, 0, 1, 0, 2. So arrays are always in what are called row-column order. That's just by default. That's the way everybody does it. Sometimes it really makes a lot of sense to set up an array as a two-dimensional array. Or even more. You can even have, for example, if you wanted to, a three-dimensional array. There's an algorithm or a little program here on 438 that shows you how you can go through and access the elements that are in a two-dimensional array. You'll notice that you have one for loop for each dimension. So if you had a six-dimension array, there'd be 6 for loops. A for loop within 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 a for loop. If you want to sum those numbers together as they show on 443, he's got a couple programs in here again that shows you this stuff. He shows you the difference as far as summing the elements in a two-dimensional array, summing the rows together, summing the columns together. All right, then he gets into these jagged arrays that you see here starting on page 445. We're coming towards the end of the chapter. There's 2 more topics, and this is one of them, and then we're finished. All right. So again, a jagged array, not every column in every row is initialized. So you set it up a little bit differently. Notice that here, when you have a two-dimensional array, normally you put the number of rows and the number of columns, but we don't know how many columns we're going to have, so we leave that blank. That's what they show you on 445 and 446. And the last thing that's covered in the chapter is the list collection. Again, a list in C# is known as an array list in Java, but that one is done at runtime. So the list, or the array in this case, but it's a special kind of an array, it's called a list. It can expand and contract as the program is running. All right, we'll get into it much more in Java. It's got a different syntax, list, and then the type, and then the name equals new list, and then the type again, paren. So it looks a little goofy. All right, we're not going to really do any work with this in this class, so I'll let you just read that on your own. Okay? So that's about the next 10 or so pages. And then finally, I'm going to jump up to page 463. Again, you'll have 2 assignments for this chapter. One is to do that array fun program that we did in class, and the other one is this population program. In the Chapter 7 folder of the student sample programs, you'll find a file named uspopulation.txt. It's already out there for you. It contains mid-year populations of the United States in thousands in the years 1950 through 1990, those 41 years. Create an app that reads the file's contents into an array. I would suggest an array rather than a list because an array is easier. Then the application should figure out the average annual population change for each year, the year with the greatest increase, the year with the least increase. All right? And that's it for this one. I'm going to come back in just a minute with the Java lecture.